Probability and statistics fundamentals. Probability and statistics are crucial part of artificial intelligence and machine learning. They help us understand uncertainty, analyze data, and make predictions. Even if you are not a mathematician, grasping the basic ideas in probability and statistics will strengthen your ability to work with AI models and interpret their results. Let's explore some essential concepts and why they matter in AI. Why probability and statistics matter in AI? AI systems often deal with real world data which can be noisy, incomplete, or uncertain. Probability and statistics provide the tools to describe and summarize data, measure likelihood to different outcomes, make decisions based on data even when uncertainty is involved, and evaluate how well models perform. Many AI algorithms rely on statistical principles from simple decision making processes to complex learning models. Key concepts in probability. Probability is a measure of how likely an event is to happen. It's always a number between 0 and 1. 0 means the event cannot happen. 1 means event is certain to happen. For example, the probability of flipping a coin and getting head is zero point 0.5. The probability of rolling a 6 on a fair die is approximately 0.167. Random variables. A random variable represents possible outcomes of an experiment or process. It can be discrete, takes on specific separate values, for example, number of heads in coin tosses. Continuous, takes on any value within the range, example, height of people. Understanding random variables is essential because AI models often predict probabilities for different outcomes. Probability distributions. A probability distribution describes how likely different outcomes are for a random variable. Examples include uniform distribution. All outcomes are equally likely. For example, rolling a fair die. Normal distribution. Data clusters around a mean value is a bell-shaped curve. Many real-world measurements like heights or test scores follow this pattern. Bernoulli distribution, used for binary outcomes like success or failure. Probability distributions are used extensively in AI to model data and make predictions. Key concepts in statistics. Descriptive statistics. Descriptive statistics summarize and describe data to help you understand it better. Key measures include mean, that is average, the sum of all values divided by the number of values; median, the middle value when data is sorted; mode, the value that occurs most frequently; standard deviation measures how spread out the data is from the mean. These measures help you quickly grasp the nature of your data. Inferential statistics help you make predictions or decisions about a larger group based on smaller sample. In AI, we often use samples to train models and then generalize those results to new data. Key concepts include confidence intervals, a range of values likely to contain the true population value; hypothesis testing, testing whether a claim about data is likely to be true; p-value, measures how likely observed results are under a specific hypothesis. Inferential statistics ensure that AI models make reliable conclusions and avoid mistakes based on the random chance. Correlation and causation. It's important to remember that correlation does not imply causation. Correlation, when two variables appear to move together, for example, ice cream sales and swimming pool attendance might both increase in summer. Causation, when one variable directly affects another. Understanding this distinction prevents false conclusions when interpreting AI results. Probability in machine learning. Probability plays a role in many machine learning algorithms such as predicting likelihood of events, example, the chance of a customer will buy a product; modeling uncertainty in predictions; assigning confidence levels to classification results; algorithms like Naive Bayes which rely on probability calculations. Practical relevance. In this course, you will see how probability and statistics are used to analyze and visualize data, evaluate AI model performance using statistical metrics, handle uncertainty in predictions, understand algorithms like regression, classification, and clustering. Don't worry if these concepts feel complex at first. We will revisit them with practical examples visualizations, and exercises to help you apply them confidently in your AI projects. Probability and statistics form the language of data. By mastering these fundamentals, you will be well prepared to build and interpret AI models with accuracy and confidence.